So let us discuss with the next chemical reaction, that is preparation of aspirin. So aspirin can be prepared when salicylic acid is made to react with acetic anhydride. So when salicylic acid is made to react with acetic anhydride, we are going to get a compound called as aspirin. So this aspirin can also be called as acetyl salicylic acid, means you can call it as either aspirin or you can call it as acetic salicylic acid. So how the reaction will take place, let us analyze. So first one should know the formula of salicylic acid. According to the name, acid indicates it has a carboxylic group. So salicylic acid has two functional group present in it. One is a carboxylic group, another one is an phenolic group, that is OH. When it is made to react with acetic anhydride, that is CH3C double bond O, CH3C double bond O. This is the formula for acetic anhydride. So when the reaction takes place in the presence of an acid, that is which contains a proton, so it gives rise to aspirin. So one particular confusion arises how this aspirin is formed. So here as usual we know that it ionizes as CH3COO minus and CH3CO plus. Okay, so this is one particular case. Here one should know that the acetyl group, that is CH3COO minus group, here this CH3COO which is positive, this binds with OH. Here hydrogen will be eliminated as a proton, so that O becomes negative. This negatively charged oxygen will bind with what? CH3CO plus, so that I can write it as OCOCH3 along with the attachment of COOH group. So this is called as aspirin. So what is left out? CH3COO minus is left out, which combines with H plus, that gives acetic acid, that is CH3COOH. This is the method how an aspirin is prepared. So now let us discuss with a new concept, that is the reactions involving the cleavage of carbon and oxygen bond, means breakage of bond between what? Carbon and oxygen bond in alcohols. So till now the concept what we have discussed, it is with relevance to the breakage of bond between O and H. Now we are discussing the breakage of bond between carbon as well as oxygen. So when we study the breakage of bond between carbon and oxygen in alcohols, the reactions involving the cleavage of CO bond takes place only in alcohols, means we can notice this type of chemical reactions, means cleavage of carbon oxygen bond chemical reaction can only take place in alcohols. Here phenols can show this particular reaction, or phenols can show this type of reaction only with zinc, means except zinc, phenols does not show this particular cleavage between carbon as well as oxygen, but phenol can show this reaction only when it is made to react with zinc. Here when we study the order of reactivity, so the order of reactivity in the cleavage of COH bond follows the order: tertiary alcohols are more reactive than secondary are more reactive than primary. So primary is more reactive as compared to methyl groups. So this is the sequence of cleavage of C as well as OH bond with reference to alcohols. So by considering all this, the first type of an chemical reaction that has to be studied is reaction with halogen acids. This is the first type. Reaction with halogen acids is the first type, or you can also call it as hydrogen halides. So reaction with halogen acids, or you can also call it as hydrogen halides. Here when we consider the reaction of alcohols, so all these alcohols can react with halogen acids to form haloalkanes. So any particular alcohol, when it is made to react with halogen acid, it can readily form haloalkanes or alkyl halides as the major product. So when we consider the reactivity of halogen acids, so these halogen acids shows the reactivity as hydrogen iodide is more reactive than hydrogen bromide, which is more reactive than HCl. So this is the reactivity with reference to halogen acids. And after knowing the reactivity of this halogen acids, the order of reactivity of alcohols, when we discuss the order of reactivity of alcohols, as we have noticed that tertiary is more reactive than secondary, secondary is more reactive than primary. We have already discussed that tertiary is more reactive than secondary, secondary is more reactive than primary, primary is more reactive than simple alcohols. But if there is an existence of allyl alcohols and benzyl alcohols, the first major reactivity will take place with benzyl alcohol, which is followed by allyl alcohol. The meaning is benzyl alcohols are more reactive than allyl alcohols, which in turn more reactive than tertiary, secondary, primary as well as simple alcohols. So by considering all this, when we discuss a reaction of alcohol with reference to hydrogen halides or halogen acid, it gives rise to alkyl halide along with the formation of water molecule. So when we discuss the particular reaction with reference to HCl, CH3CH2OH, which is nothing but a primary alcohol. So when this primary alcohol is made to react with hydrogen chloride gas in the presence of anhydrous zinc chloride, it gives rise to CH3CH2Cl, which is nothing but ethyl chloride along with the formation of water molecule. Suppose if I take an secondary alcohol, so secondary alcohol means two hydrogens are replaced by two alkyl groups. So this is called as 2-propanol. So when this 2-propanol is made to react with HCl in the presence of anhydrous zinc chloride solution, we will get 2-chloropropane, that is CH3 with one more CH3 with hydrogen along with Cl, which is called as 2-chloropropane. So along with this 2-chloropropane, we will get what? Water molecule. Suppose if there is an involvement of tertiary alcohol, so a tertiary alcohol is one in which all three hydrogens are replaced by three alkyl groups. So this is an tertiary alcohol. When it is made to react with HCl in concentrated condition by maintaining only a room temperature, it gives rise to tertiary butyl chloride, that is CH3 thrice with Cl along with the formation of water molecule. So here these are the reactions of primary, secondary as well as tertiary alcohols when it is made to react with HCl. Suppose if we discuss the same reactions with HBr, that is hydrogen bromide. So when I discuss with primary alcohol, that is CH3CH2OH, when it is made to react with HBr in the presence of concentrated sulfuric acid, upon refluxing the chemical reaction, we are going to get ethyl bromide. So along with ethyl bromide, formation of water molecule will take place. So when we discuss the further reactions with secondary and tertiary alcohols, for secondary and tertiary alcohols, no catalyst is required. So there is no involvement of any catalyst when the reaction takes place with secondary and tertiary alcohols, because they undergo dehydration. because they undergo dehydration in the presence of what? Concentrated sulfuric acid to form their respective haloalkanes. Suppose if we discuss the same chemical reactions with reference to hydrogen iodide. So when the reaction is taking place with hydrogen iodide, when methyl alcohol, here alkyl iodides are readily formed on refluxing alcohol with constant boiling hydrogen iodide. So the meaning is that we can readily get alkyl iodides, and these alkyl iodides are formed on refluxing. These alkyl iodides are readily formed on refluxing. Alkyl iodides are readily formed on refluxing, Fluxing, on refluxing alcohol with constant boiling hydrogen iodide, which is maintained at 57%. That is, when CH3OH is made to react with HI, which upon subjecting to refluxing, it gives rise to methyl iodide along with the formation of water molecule. So due to that reason, we tell alkyl iodides are readily formed on refluxing alcohol with hydrogen iodide HI, by where the concentration of HI is 57%. Suppose when an alcohol, here generally we can tell that when an alcohol is made to react with hydrogen iodide in the presence of red phosphorus by maintaining a temperature of 423 Kelvin, an hydrocarbon, that is methane, is formed along with the formation of water molecule and liberation of iodine. This reaction readily tells that when alcohol is treated with hydrogen iodide in the presence of red phosphorus, the reduction takes place. Here alcohol has undergone the reduction to form methane as the major product.